Hi, everyone. Thank you for joining us today at RSA Conference, albeit virtually. We're really excited to be here today to talk to you a little bit more about 5G security. My name is Courtney Lang. I am our Director of Policy at the Information Technology Industry Council, where I cover a wide range of issue areas, including cybersecurity and 5G security. For those of you that aren't familiar with ITI, we are a global advocacy organization representing over 75 of the world's leading innovation companies. So we have members ranging across the technology sector, hardware, software, digital services, platforms, you name it, we probably have it. So our panelists today are actually all ITI member companies. So we're really excited to have them here today to talk a little bit more about how governments around the world can promote a secure 5G ecosystem. I'll start by providing just a bit of context for the panel, and then I will go ahead and introduce our panelists, and we will jump into the discussion after that. So with that being said, I'm sure for many of you watching today, you might be familiar with the fact that countries around the world are taking steps to deploy the next generation of network technology, also known as 5G, and really looking to reap the benefits of this transformational technology and all the things that it will enable. Simultaneously, as this is happening, we are also seeing concerns kind of increasing around how to secure these networks, particularly because 5G networks are undoubtedly critical infrastructure. I think it's become more apparent than ever how much we rely on it, especially during the pandemic. And so it's something that we've also seen policymakers take an increased focus on. We've seen new ideas emerging around how to avoid things like vendor lock-in. There's been, a heavy focus on open radio access networks, for example. We've also seen regional tools emerging, things like the EU 5G security toolbox, really aimed at addressing a full range of risk across the 5G ecosystem. We also need to think a little bit more about 5G's evolution, particularly as we move from non-standalone to standalone, and as more and more parts of the network rely upon new 5G technology to create an end-to-end network. There are new and different components, almost all of which are being considered in a virtualized or containerized environment. And so this is something else to keep in mind, and I think something that we'll touch on today in our panel. And finally, as governments look to promote secure 5G, one of the things that we're really seeing is kind of this narrow focus on supply chain actors and equipment. And certainly this is important, but it's not the only thing to consider. And so, sometimes this can be detrimental to other risk factors that should be taken into account when thinking about the security of 5G networks. So our panel today will explore the idea of a secure 5G ecosystem, and our panelists will offer thoughts on ways in which policymakers can help to enable a holistic approach to 5G security that addresses threats and risks to the networks, as well as the information, applications, and services that will run on top of them. So with that, why don't I introduce the great group of panelists we have here today, and then we will jump into the conversation. I will introduce Danielle Kriz first. She is Senior Director of Global Policy at cybersecurity company Palo Alto Networks, one of ITI's member companies. We also have Shehzad Merchant. He is the Chief Technology Officer at Gigamon. And we also have Scott Charney, Vice President of Security Policy at Microsoft. So thank you all for being here today. Really looking forward to having a conversation with you about all of the topics that I just alluded to. So I think perhaps the best way to start is with kind of a context setting or level setting question focused on kind of what the landscape is looking like out there. So the first thing I'll ask, and feel free to kind of jump in any order, but is about, whether you can talk a little bit about what trends you're seeing with regard to how governments are looking at 5G security around the world, and how are countries thinking about security in the context of 5G? What policy measures are they taking? And are there any kind of emerging trends that you're seeing to address the perceived risks?
Courtney, I'll start if that's okay.
Great.
Thanks again for having me here at RSA, although virtual. Hopefully next year we'll be in person. I think as Courtney mentioned, a lot of governments around the world are paying a lot of attention to 5G security, and they absolutely should. One trend that I've seen, but I think is slowly beginning to change, is there's been a little bit of a focus in the last few years on vendor, right? Who is building the network and what is the supply chain that's going into building 5G networks? And a policy response has been related to keeping certain vendors out of the market. But I'm seeing a bit of change, and I think that's the change is the right thing. As Courtney mentioned, there are many, many aspects to 5G security, which we'll get into later in the panel. But there have been some governments giving guidance on 5G security and looking at 5G security more broadly. I think one important example is in the EU. You mentioned the 5G toolbox, but aside from that, there is something called the European Electronic Communications Code, which is a fancy name for the EU's latest telecom legislation. There are some security requirements in that, and in December 2020, the European Union Security Agency, ENISA, issued some supplementary guidance on 5G security. It's aimed at the telecom regulators of all 27 EU member countries, and that guidance calls for the use of technologies such as network slice security, secure containerization, real-time monitoring for threats going across networks. So there's other examples as well, but we're definitely seeing governments look at this more holistically. And I'll see if my other panelists have anything to add.
So this is Scott Charney. And what I would say is that governments are becoming more sophisticated in thinking about the threat models of 5G. And so you have, as you mentioned before, we're moving from a place where 5G is mostly in the endpoints and the radio spectrums, but you're running on the 4G backbone, to a place where it's really going to be cloud-enabled end-to-end with virtualized networks and software-defined networks. And that poses a whole different threat model. And you see a lot of focus on how do we ensure we're building secure code and adopting operational practices that are more robust and starting to leverage the new technologies, machine learning and AI, to look for anomaly detection and response work. You see a lot of that unfolding now, and governments looking for ways to incentivize the right behaviors, either through purchasing models of what they buy to regulatory models of requiring things. And the other thing I would say is, while there was a lot of early furor over country of origin, and often company of origin, and company is a proxy for country in that context, that issue remains front and center. And I think the reason for that in part is, as I say to people, the US would not buy its fighter jets from the Russians. And even if the Russians said, well, but we'll be transparent about how we built it and what's in it, you still wouldn't do it. And I think the interesting thing is that if you go back 40 years, governments embraced COTS, commercial off-the-shelf software, because it was inexpensive and fully featured. And then they put these COTS commercial products into their militaries and other places. And now they realize their military might be dependent on an adversarial nation, and that's just the problem. And so I think you'll continue to see focus on that and some more polarization in the world. So the government's grappling with all of these issues at once, and it's a lot on their plate.
I'll chime in and maybe add a little bit to what Scott mentioned. Certainly there is a strong emphasis on supply chain and looking at all aspects of the supply chain when it comes to 5G. But I think what people are beginning to realize, and governments are beginning to realize this as well, is that there's a pretty significant shift in terms of how we built our mobile networks, in the 2G, 3G era versus moving forward to 5G, even 4G to 5G, where all the network functions are getting virtualized, right? And these network functions are coming from different vendors, different suppliers, And so we've gone from, in some sense, a monolithic, vertically integrated system to a completely distributed software system. And that is leading to a massive expansion and explosion in the surface area of attack, right? 5G is essentially moving to a services-based architecture where these services are now coming from open source components. They're coming from commercial vendors. They're coming from contractors. And when you sit and think about security in that arena, I think what we should be doing is taking a page out of everything we've learned in the world of IT security, because 5G is beginning to look more and more like that environment, and bring those principles into the 5G world.
Great. Thanks, everyone. I think that was a pretty helpful level set to kind of talk about the things that are happening around the world. A couple threads in there that I'd like to pull on a little bit. And I think, Shehzad, you got into that a little bit in your previous remarks, but just to dive a little bit deeper, I think it would be helpful to talk a little bit about how threats might be different in the context of 5G, and how they might be the same, and kind of what is changing with regard to the security calculus with this new generation of network technology.
Sure. So I'll kick it off, and then maybe Daniel and Scott can add to that as well. So, when we sit and think about 5G, we typically, think about faster speeds, right? That's the first thing that comes to mind. 5G is a lot more, right? 5G is about faster speeds. It's about lower latency. It's about lower power consumption. It's about higher capacity. There's a whole set of vectors that 5G brings to the table. And in order to accomplish all of these objectives of 5G, there are some fundamental architectural changes that 5G brings to the table. For example, one key aspect of 5G is something called network slicing. And what network slicing does is essentially carves out a portion of the 5G network, both the radio access network and the core, and assigns it to a certain class of applications. For example, you could carve out a slice of 5G for autonomous driving, right, to guarantee low latency, because you want it to be low latency if you're in a vehicle that's driven autonomously. You can carve out a slice of the 5G network for critical infrastructure, right? But this kind of a model leads to a different set of threats, right? Which is that even though these slices are assigned to these different industries, the underlying service-based architecture is common in some sense across these slices. And so can you actually mount an attack from one slice to another slice? And this is exactly what is being explored. In fact, there was a pretty significant disclosure last month in March around some of the security threats pertaining to network slicing, as an example, and what are some of the things we need to be thinking about. So I think there are some nuances of 5G that lend themselves to very different kinds of attacks. And what we have to realize is that when we think of cybersecurity, in the traditional world, we typically think of confidentiality, integrity, and availability, right? And those are the three key vectors of cybersecurity. And we've mostly focused on confidentiality. But when we sit and think about security in the world of 5G, the attacks are going to be more on the integrity and availability of systems. And attacks on integrity and availability tend to have far more dire consequences than attacks on the confidentiality of information, right? So I think there are some pretty significant shifts in the 5G world that we have to sit and think about. Scott, Daniel, anything you'd like to add?
Yes, I think that was a great summary. And as these IT models change, the threat models change, and network slicing is an opportunity for bad guys, as well as something that might be good for us. But I'd also say the other thing to focus on is scale. I mean, one of the things about 5G is the sheer number of devices that will be out there and connected. You see these incredible numbers of machines. And it also affects the way we have to think about how do you build a secure 5G infrastructure. More specifically, for all the time I've been in computer security, people have talked about educating developers to write secure code, et cetera, et cetera. And that's great in educations like mom and apple pie. The problem is it doesn't scale. If you're going to have billions or hundreds of millions of developers around the world, or millions of developers, how do you get them all to write secure code? You're not going to educate your way out of the problem. And therefore, we have to focus on how do you do these things at scale. For example, one of the things we found at my company, Microsoft, of course, is that if you're developing code, you really want the code analyzers, the static analyzers, and other security tools to run as part of the development process in the platform. So that people who are developing code, even if they're not security experts, get the benefit of security in the platform development model. And when you think about reliance on open source, the idea that you're going to educate every open source developer in the world to build good threat models and write secure code is just not going to be successful. And so, but if you build into the platforms, the security tools and other things that you need, is how you get to scale. And we have to think about that not only in developing code, but operational practices. The only way to get to scale is through massive automation that builds and manages security automatically as the networks run.
And I want to add a few things to these great remarks. I think, one thing that Shehzad mentioned that's really important to think about is, this is about digital transformation, right? So 5G, it isn't just faster speeds and lower latency and these great things we hear about. It's a completely different way of doing business from the 3G and 4G era. And so companies as well as governments around the world are going to be leveraging 5G for digital transformation. It's a mission critical part of their business, or it will be. It's not just a nice communications tool. So we see governments, leveraging 5G. We have some pilot programs and efforts in the US in our military. I know that's happening around the world, but a lot of manufacturing companies and other types of companies are leveraging 5G also. So if it becomes a mission critical, kind of enterprise critical type of technology, as Shehzad said, he called it kind of an IT, you need enterprise grade security, right? So your security has got to be much stronger than what may have been acceptable in earlier generations. I think picking up on the comments about new technologies of 5G, such as slice security, in areas like containerization, for example, like the core is being built containerized. There is also innovation going on in the cybersecurity field of how you secure those areas, right? So we're aware of these transformations in 5G that need to be secure. So you can have 5G slice security, you can have security of containerization. So I think the threats are definitely larger and changing, and the technology responses are as well.
Hey, Courtney, if you don't mind, I'd like to just do a quick follow-up to some of the comments as well, because I think these are important points that were made by both Daniel and Scott as well. And that is, if you sit and think about any security strategy, right, one of the learnings we have from the IT world is that you have to build resiliency, right? You can't have a single point of failure. And security is multi-tiered in that sense, right? You build layers and layers of security in your overall stack. And when we sit and think about the applicability of this in the 5G world, Daniel talked about the fact that the core is now being built, for example, using containerized functions, right? And virtualized functions as an example. Scott talked about scaling as a big challenge as well. And so I think one of the ways to bring all of this together, right, because you will have some functions coming from certain vendors, other functions from other vendors, some running in containers, some running in virtual machines, some running in hardware as well. And all of these ultimately are going to be tied together by the mobile network operator, right? They're the ones who are putting it all together. And the glue, in my view, that ties all of this together really is the network, right? Because all these containerized functions talk to each other over a network, right? The virtual functions talk to each other over a network. Anytime there's a bad actor, there's any command and control activity, it happens over the network. Data exfiltration happens over the network. Lateral movement happens over the network. And so I think in a world where many of these 5G functions are going to come from different vendors, in a world where the underlying technologies are going to come from different vendors. The container technology may be open source technology, it may be commercial technology. The functions running on that may be coming from different vendors. You need some glue that binds it all together and can provide to you an end-to-end perspective on tying some of this. And so I think increasingly the role of network-based security in 5G environments, I think, is going to increase as really the glue that brings it all together. I just want to toss this out, and maybe if people have comments on that, that's great, or we can move on as well.
Great. Yeah. Thanks, Shazad. I think, perhaps we can roll along into the next question. I wanted to focus a little bit more on some of the kind of policy questions that have been brought up here today, and talk a little bit more about a couple of themes that were raised in some of the opening remarks. Scott, in particular, I know you raised country of origin as something that has been a focus. And I think one of the questions that I wanted to pose to folks, and I think that would be useful to people that are watching this, is, what role should country of origin play in security policy, particularly as we're talking about 5G security? I think, would be interested to hear your perspectives on kind of where that should sit in the grand scheme of things. And as we're thinking about network security more generally, what role that should play.
Well, I certainly think in the context of government functions and critical infrastructures, country of origin will continue to play a large role. And, one can just imagine a scenario where in some sort of geopolitical conflict, your telecommunication systems became unavailable and your populace learned that you were completely dependent on adversarial product to run your network. And that turned out to be a really bad idea. I think the challenge for governments, for policymakers, is they're twofold. One is the global supply chain is an integrated global supply chain. It's fine to say, let's just bifurcate everything out and split everything apart and have a polarized environment. But there's really no country on the planet that can create everything today, or trusted groups of countries. And so there is going to remain dependency on one another, even if it makes countries uncomfortable in some contexts. And so going back to what Shazad said, part of all security is defense in depth. So you have to figure out, if you have some supply chain risk that cannot be eliminated because it's about risk management, not risk elimination, how do you figure out how to manage the residual risk and yet still have a relatively safe environment, for your purposes? And then the second thing is, you don't want to throw the baby out with the bathwater. So, for example, you might be concerned about having adversarial product running the communications of the White House, but that doesn't mean that people shouldn't buy a baby monitor made from a foreign entity, or other kinds of technology that just doesn't pose the kind of national security and public safety risk that governments tend to worry about. And the real challenge is trying to sort that out and figure out what's in what bucket. If you think about things like microprocessors, well, they're in everything. So it's not like you can, have them in some things and not others. But there are certainly functions and that you worry about in terms of critical functions that you're going to be more aggressive about source. And that's why you see governments, as a matter of policy, looking at things like SBOM, software bill of materials, and hardware bill of materials. So at least when you're purchasing, you understand that the risk that you're accepting, where the product comes from, where it may have been developed. And then, how do you actually certify products so you can say, okay, this was built pursuant to good security practices and processes versus something that wasn't. And so it's going to remain a factor, and the key will be trying to narrow your exposure and then manage the residual risk.
So, maybe a quick comment from my end as well. This is a complex problem, right? Country of origin is an issue, but in my mind, it's one vector to be thinking about. And it's a lot easier dealing with country of origin when it comes to hardware, when it comes to chips, right? I mean, where is this chip manufactured? Where is the system assembled, right? Where is the manufacturing facility? Country of origin becomes very difficult to deal with when it comes to software, right? And I think this is the big shift that's going on in the world of 5G. Yes, there's always going to be hardware, but increasingly, when you sit and think about the core, moving away from the RAN, if you sit and think about the core, it's running on servers, right? And it's running on servers because everything is essentially moving towards a software model, and where your software is essentially getting pulled from open source. As an example, you're using Docker, Kubernetes, or you're using microservices architectures like Istio. It's hard to say what the country of origin is because it's really difficult to track who's contributed to that open source and what backdoors have been inserted into that open source, right? So I think country of origin is important, but it is one vector, and it's one vector that you can deal with relatively easy when it comes to hardware, but it gets far more, murky when you move beyond the hardware and start looking at software. And I don't have any easy answer to that. I'm just pointing out that that's an issue.
And let me add to Suzanne's point. It's a good one. It's not just open source. I mean, I could go back years and I would have some governments say, Windows is made in America, in Redmond. And I go, yes, by a workforce that is international in scope. I mean, we have everyone from everywhere writing code. And so, software, whether it's open source or proprietary software, may be made by the international community. That's just the reality of it.
Scott, there's one if it's okay to maybe be a little controversial as well. I just want to come back on the baby monitor thing, because it's an area that's I've thought about and we've chatted about in the past in multiple areas as well. I don't think we should be careful even when buying baby monitors, because what happens is vulnerabilities transcend systems, right? So we all know about the Mirai botnet, which I think 2016, 2017, which was essentially malware embedded into a bunch of home equipment like video surveillance, cameras, right? Home camera systems, DVRs, which essentially mounted a massive attack on DIN, which was a DNS provider, which brought down portions of the entire internet, right? And so, when those kinds of systems, the collective power of these kinds of systems can bring down portions of the internet, there is potentially an impact in thinking about country of origin, even for these consumer goods.
It's an interesting point, but I wonder if it's really about country of origin or the process by which the product was made. So if you take a country of origin approach, you'd say we cannot allow China, Russia, various countries to sell baby monitors in the US, hard stop. And then you go into a complete, okay, we can't take any product from any other country because it connects. The problem with the Mirai botnet in part is, if you don't have an updating process, if you have default passwords, if you have bad practices, you're going to put everything at risk. And so, but you're right, it's very hard. Like, our baby monitors, where do you draw the line? And then is the baby monitor on the safe part of the line or the non-safe part of the line for country of origin? It's really hard to make those.
It totally is. And maybe bringing it back to this, the policy conversation, because I know Courtney wants to keep us on track a little bit here as well. Bringing it back to policy, this is a policy conversation, right? Which is that, how do you incentivize the right buying behavior? Right. And from a consumer perspective, when we go and buy things, we don't look at the security thing. When people buy baby monitors, they don't look at the security of that. And so I think, when you extrapolate that even to the world of 5G, I think there has to be policy that drives security, because sometimes the buyers do not know what to look for in terms of security footprint.
Let me add to pull on a thread that a couple threads have come through. I think, it's not only incentivizing the buyer, but it is incentivizing the producer, right? And so, I think Scott alluded to as well, secure software development and these practices that companies take. So, again, the country of origin aside, governments should be incentivizing good supply chain practices by any ICT vendor, right? Because there's so many different technologies that are going into 5G networks. Again, you can't completely eliminate risk, but you can manage for it. And one of the things you can do is to help identify and point out what are some of the really good supply chain practices out there, whether they have to do with hardware or software development or end of life or anything, how you treat your code as you develop it, and then incentivize good behavior. That could be through procurements, it could be other ways, but there is an important role that governments can play to try and improve things in that way.
And I'd like to build on that, because one of the challenges governments have is to figure out how you measure those practices and certify products. Those of us who've been around for a long time know that the governments use common criteria, for example, to evaluate products. And they would evaluate a product and certify it years after it had been in the market and the next version had already shipped. And they would certify a product which would still then be hacked because it had all sorts of challenges. So we do need the right processes, of course, But one of the challenges for governments as a matter of policy is how do you then say, okay, this product followed the processes with enough rigor that it's okay to actually purchase? And that's a hard problem.
Yeah, and I want to pick up one thing on the Mirai botnet example as well, because I think, that's an example of an attack where, the only way to really stop cyber attacks successfully is if you're trying to stop it at all the parts of the cyber attack life cycle, right? I mean, the cyber attacks are not just one and done. You have to do reconnaissance and you penetrate a network and beam back and get instructions, and it's a multi-step process. And so, cybersecurity, whether you call it defense in depth or making sure that there's protections and preventions at all stages of a cybersecurity attack life cycle, policies like that promote that type of investment by enterprises or anybody, kind of bringing it back to 5G. If you're investing in 5G, making sure that you're able to stop attacks at various points in time, I think is very important. And so that's something that government should be incentivizing as well.
Great. I want to be mindful of time here. So maybe just one other question to kind of wrap us up here. Obviously, what we're trying to do today is share perspectives with policymakers about what they can be doing to help move the needle forward on 5G security in a way that is really holistic and comprehensive. And so I think, it would be interesting to hear, and I'm going to meld two questions together here, what your top recommendations are for governments as they're seeking to deploy and or support the secure deployment of 5G networks. And as a part of that, I think one of the things that we've seen is kind of this tendency or desire by governments to view 5G security through the lens of trustworthiness. And that's something I know in the US that has been, talked about pretty significantly is what makes a vendor trustworthy or a vendor trusted. So kind of tying those two together, would be interested to hear your top recommendations for governments, but also, when thinking about trustworthiness, perhaps key criteria that should go into that consideration if governments are using that as a measurement of whether or not a vendor can be used in a network.
Well, I'm happy to start. I think I'd say a couple of things. One is the government need to focus on secure development and operational practices holistically, which I think they are doing now. They need to always think about scale, which is, does this solution for those things actually scale across this incredible IT infrastructure we built? And they need to think about standardization, because if we're going to sell in a global market and you're going to have vendors from all over the world, whether hardware or software, you need, industry-led, government-participated standards. We have to think about how do you measure the success of following these practices, and then how do we leverage emerging technologies, particularly machine learning, AI, to do anomaly detection, because all the great security in the world will not stop the attacks, right? People will continue to try to attack, and at the scale that we will be working, being able to define what's normal versus what's anomalous will be a challenge, and I think the machines can be a huge help in figuring that out and then pointing people at remedial actions that we can execute on quickly.
I want to pick up on what Scott said. I have, for my recommendations, machine learning and AI are absolutely essential. I mean, companies like ours, and I'm sure colleagues on the panel, we're using machine learning and increasingly AI to do our cybersecurity, to deliver solutions and to secure our customers. And it's not only detecting the anomalous behavior, you can use machine learning and AI to automatically prevent and stop that behavior from moving forward. So there's great advances in machine learning and AI for cybersecurity generally that are happening all the time that can and need to be leveraged for 5G. I think my second recommendation may be kind of very, very simple for those of us on the panel, but hopefully it is useful, is really about the absolute need to involve industry in any policymaking thinking or development. this field is moving very quickly. IT always moves very quickly, so does cybersecurity. So any type of government policy response to issues that they want to try and fix, you have to be involving companies like ours and many others in the discussions. Like we're looking at cyber threats constantly. We're constantly innovating in areas that are really important to 5G security, whether it's slice security or securing the various layers like the data layer and signaling layer and others. And we can help be part of the answer and the solution. And so I think governments working with companies like ours and other stakeholders, that's really integral to a successful policy.
And so I'll tack on a slightly different dimension. By the way, I agree completely with Danielle and Scott, but I wanted to bring on a slightly different dimension in terms of one of the things I could potentially think about recommending as well is that when you sit and think about 5G, as I mentioned earlier, there are multiple components all coming from different places, right? So, for example, one part of 5G is the mobile edge, right, or multi-access edge computing, or MEC, which is really, you just sit and think about it's the cloud, but closer to the edge so that you have lower latency. And that cloud is going to be provided by cloud service providers, right? And applications will run on top of that. And just like in the cloud, as we think about AWS Azure that has a shared security model, there will be a shared security model because somebody's going to build an autonomous driving app on top of the MEC solution running over 5G. And if there's a compromise in that model, who's responsible for the failure, right? Is it the cloud provider? Is it the application provider? Is it the mobile service provider? Because there are multiple entities here, right? And so I think from a regulatory perspective, and I don't like more regulation, but I think in this situation, there probably needs to be more regulation from the security side, I feel, on the mobile service provider side. And this worked really, really well in the credit card industry, right? When the onus was put on the credit card issuers to deal with fraud, initially there was a pretty big backlash, but they evolved some pretty sophisticated systems to detect fraud. And the onus was not on the consumer. The onus was not on the point of sale provider. It really came down to the credit card issuer. And I think perhaps that may be a page to draw over here and say that if you have the cloud service provider, you have the consumer, you have the mobile service provider, you have all these different entities, perhaps the entity that's really offering the service, which is the mobile service provider, should be responsible and should have a greater onus on their shoulders for the security of that infrastructure, even though the components are coming from a bunch of different places as well, right? So maybe that would be my thinking in terms of regulation and recommendations, is to put a little more onus on the mobile service provider for taking ownership of the overall security.
And can I add one other kind of different point? Which
briefly, we're very close to our end of panel here.
Even if we do all this security right, we will still be attacked because there's a lot of geopolitical conflict in the world. And I think industry needs to engage more on international norms and how we think about what is acceptable behavior on the internet, even among nation states. There are some in industry who go, well, that's a government function. But if you look at the attacks, whether it be SolarWinds, Stuxnet, or whatever, industry is often the first to detect and respond, even to nation state attacks. And we need to lower the volume of that kind of activity on the internet to make it safer.
Great. Well, with that, I want to thank everyone for taking the time today to share your thoughts on 5G security. Time flies, so we're already at the end of our session, but certainly welcome folks in the audience to ask questions in the chat box of our panelists. We really look forward to answering anything you might wonder about based on the comments that you heard here today. So thanks again for having us at the RSA conference this year, and we'll look forward to your questions.